Welcome to Ask and Learn.
In problem 21, we have a Carnot cycle again. And in the first item of this problem, item A, we have to find the minimum pressure of this Carnot cycle. So, how do we manage to find the minimum pressure? Well, let's think about that the minimum pressure can be determined by the entropy change. Okay? So we know that the entropy change is going to be just Cp natural log of T4 T3 minus R natural log of P4 P3. Therefore, if we rearrange this, we know first of all that this is going to be equal 0. Therefore, if we rearrange this equation, we find that P3 is going to be equal P4 the exponential of minus delta x, which is the change in the entropy, divided by R. Okay? We just need to use the change in the entropy. But the problem here is we do not have we do not have the pressure 4. Okay? So since we do not have the pressure 4, we need to find a way to find this pressure, so then we can find the minimum pressure. Well, how are we going to find this? Let's think about the network, okay? Because just one moment. Before we think about the network, we want to find the pressure 4. That is correct. So, what equation we can describe, we can solve that involves the pressure 4? We know that the transformation between 1 and 4 is an isentropic transformation, which means that P1 is going to be equal P4 that multiplies T1, T4, K minus 1. That is correct. So as we can see, in this isentropic transformation we have P4. So the only problem here is we have to find what is the temperature. So we do not know the low temperature, which is the temperature 4. Again, we have another problem. So to calculate the minimum pressure, we need P4. And to calculate P4, we need the low temperature. And how are we going to find the low temperature? Well, we're going to use the network, because the network is just the area of the TS diagram. So it's just the change in the entropy S2, S1 with TH minus TL. Therefore, this is just 100, that is equal 0.25, the entropy increase, which is 950 minus TL. Therefore, from here, we take that TL is equal 550 Kelvin. Alright, now that we have the temperature 4, we finally can calculate P1, because this is going to be actually not P1, sorry, we can calculate P4. So P4, this is, let me see, this is 1300, that is equal P4 950 divided by 550 to the power of 1.40.4. Therefore, from here we take that the pressure 4 is just 191.9 kilopascals. Finally, now that we have the pressure 4, we calculate the minimum pressure. So the minimum pressure is going to be 191.9 exponential of minus 0.25, which is the entropy increase, divided by 0.2 87, which gives us precisely 80.3 kilopascals. That's the minimum pressure of this Carnot cycle. The second thing we must do in this problem is to find what is the output heat. So item B, we have to find the output heat. As we know, the output heat is related to the low reservoir. So this is just TL delta X, delta S. So since it's the low temperature of the cycle, this is just, let me see, 550 that multiplies 0.25. Therefore, the heat output is just 137.5 kilojoules per kilogram. And finally, actually we have two more items. Item C. Item C, we have to find the Carnot efficiency. And the Carnot efficiency is just 1 minus TLTH. This is going to be equal 1 minus 550,950, which gives us a Carnot, gives us a Carnot entropy of 42.1%. And the last item now is the last item, item D. We need to find the second law efficiency, and we know that the second law efficiency is determined from the Carnot output. So the Carnot output, the second law efficiency, is going to be the net work divided by the Carnot work, and this is just 5200, which is the net work, divided by the Carnot work, which is just 95, which is the mass, times the work, and the work is 100. Therefore, the second law efficiency is 0.547, or if you want, 54.7%. And that's the final answer to this problem. Thanks for watching.